Now let us discuss about the signal descriptions of 8086 microprocessor. Before going into this concept, let us discuss about the concept of processor modes. The 8086 works in two types of processor modes. One is minimum mode and the next one is maximum mode. In minimum mode, the 8086 processor works as a single processor alone. In maximum mode, the processor is attached or interfaced with the co-processor. In maximum mode, the processor is attached with or interfaced with co-processors such as 8087 and hence it is called as multiprocessor modes. The processor mode refers to the way in which the processor executes its functions. That is, based on the environment, the modes can be classified as single processor mode and multiprocessor mode. So this is about processor mode concept. Based on this, 8086 processor also acts in two types of modes, that is minimum mode and maximum mode. Now let us discuss the each and every pin functions. So this is the signal description of 8086 and it is a 40 pin DIP. That means DIP refers to dual inline package, and on this left side there are 20 pins configured from top to bottom fashion, and on the right hand side there are also 20 pins and they are configured from bottom to top fashion. And the processor and the signal descriptions of 8086 are classified into three ways, that is signals having common functions besides minimum or maximum mode. So there are totally 32 pins that exhibit such type of function. And the second is pins that have special functions when the processor operates in minimum mode. So the total number of pins is 8, and the third one is pins that operates the pins that operates in maximum mode alone, that's also 8 pins. So this is the three ways of classifying the signal description of 8086. Now let us discuss about the pins that have common functions. The total number of pins is 32, and the first pin is ground and the 20th pin is also ground. So there are two ground pins in 8086 because 8086 is a high digital frequency circuit, and if it has two ground pins and it is able to resist so the first pin is ground pin and the 20th pin is also ground pin, and this 8086 is a high frequency digital circuit and hence it consists of two ground pins. And the second pin and next is pin number 2 to 16 and the pin 39. So these pins are called as multiplexed address and data pins. It means that these pins will act as address pins and as well as data pins. We know that in 8086 there are 20 bits used for address lines and 16 bits used for data lines. In this 20 bits, 16 are called as lower order address pins and the remaining 4 bits are called as higher order address pins. And in this 16 bits of data bus, 8 bits, that is from D0 to D7, they are called as lower order data bus, and the remaining 8 pins D8 to D15, they are called as higher order data pins. So this is the classification of higher order address bus and lower order address bus, followed by higher order data bus and lower order data bus. So this is the classification. So this pin number 2 to 16 and 39 will act as multiplexed address and data pins. It means that during T1, that is during the first clock cycle, these pins will act as address bus, that is they are used to carry the address bits, that is lower order address bits, and in the remaining clock cycle they will act as data bytes. Next pin is pin number 38. Pin number 38 to next is pin number 35 to 38. So these pins will act as multiplexed address and status pins. It means that during the first clock cycle, these pins will act as address bus, that is they are used to carry the higher order address bus, and in the remaining clock cycle they will act as status pins. These status pins are used to refer to various operations executed by this 8086 processor such as opcode fetch, read function, write function, halt, etc. And the next pin is NMI, pin number 17. Pin number 17 is called as NMI pin. NMI refers to non-maskable interrupt pin. So this non-maskable interrupt pin is used to indicate whenever any interrupt request is given through this pin, then the processor have to suspend all its activities and have to attend the interrupt request provided through this pin NMI. That is the function of a non-maskable interrupt pin. And next pin is 18th pin, and this is called as pin number 18 is called as INTR pin, and this is also an interrupt request pin. Through this pin, any peripheral device or IO device can send interrupt request to the processor. And next is the CLK, that is clock pin. Pin number 19 is called as clock pin, and this is used to receive the clock input, and it provides the basic timing necessary for 8086 processor to perform its various functions and provide the necessary control signals for each and every operation executed by this processor. So that is the function of clock pin. And we have already discussed about the ground pin. The two ground pins, they are used to get the ground supply. And next pin, 21st pin. Pin number 21 is called as reset pin, and this reset pin is used to when this pin is high, active high. We have already discussed about the concept of active high and active low. We have already discussed the concept of active high pins and active low pins during the pin description of 8085 microprocessor. When we recall that active high means when any active high pin gets the positive power supply, or when logic 1 is applied to this pin, then it executes its corresponding function. If the pin is active low, then it will execute its special function or execute its basic functionality when logic 0 or negative power supply is applied over that pin. So that is the concept of active high and active low pin. So this is the reset pin, and it is active high. When this pin is active high, then it resets all the operations of the 8086 microprocessor. And this reset pin requires a minimum of 4 clock cycles to be active in order to reset the entire 8086 microprocessor. It should be active for at least 4 clock cycles to reset the 8086 microprocessor. And next is pin number 22. So pin number 22 is called as ready pin, and this ready pin is used to indicate that the slower IO are ready to transfer data with 8086 processor. It is also active high pin. When this ready pin is active high, then the slower IO can when this ready pin is active high, then the slower peripherals can able to transfer data to and from 8086 processor. When it's low, then the processor will be in the wait state. Next is the test pin. Pin number 23 is called as test pin and it is an active low. The active low pins are indicated by bars over the name of the pin. So this is the test is the active low pin and it is connected to the busy pin of 8087 microprocessor. And this busy pin is and pin number 23 is called as test pin and this test pin is connected to the busy pin of 8087 math coprocessor. And when this test pin is low, it indicates that the execution continues between this 8087 and 8086, and when it's high, then there is no execution. And pin number 32 is called as read pin and it is also an active low signal. It means that the processor performs its read operation using this pin. And pin number 34 is called as BHE and it is also an active low pin and it is multiplexed with S7, that is status pin S7. So BHE refers to bus high enable. When this pin bus high enable is active low, it indicates that valid data is transferred over the higher order data bus, that is D8 to D15. Valid data is transferred over the multiplexed address and data lines and it from D8 to D15. So that is the function of BHE. And VCC is called as power supply and it requires plus 5 volt power supply to perform its functions. So these are all the and the last pin that executes the common function is min-max pin, that is pin number 33. It is the min-max pin. So this pin is used to select whether the processor have to operate in minimum mode or maximum mode. If the value of this pin, that is 33rd pin, is 1, that is when logic 1 is applied to this pin, then the processor will work in minimum mode. And if the value of this pin is 0, that is when logic 0 is applied to this pin, then the processor operates in maximum mode. So these are all the pins that have common functions besides minimum or maximum mode. Next we will discuss about the functions of minimum mode pins. So pin number 24. Pin number 24 is called as INTA pin and it is an active low pin indicated by the bar over the INTA name and it is called as interrupt acknowledgement. So whenever the processor gets an interrupt request via 18th pin, then if the processor is able to handle the request, then it sends an acknowledgement via this pin 24, that is called as interrupt acknowledgement. Then the 25th pin is called ALE pin. So that is address latch enable. So this address latch enable is used to indicate transfer of valid address over the multiplexed address and data pins. That is, this pin is connected to the enable pin of latch 8282 and this latch is used to separate address lines from multiplexed address and data lines. So that is the function of this pin ALE. Next, pin number 26 is called as DEN and it is an active low pin, that is data enable. So this pin is connected to the transceiver 8286 and the function of this transceiver is used to separate data lines from the multiplexed address and data lines. So similarly, ALE is used to separate address lines from the multiplexed address and data lines, and this DEN, data enable, is used to separate data lines from address and data lines. So this is the function of ALE and DEN. Next, pin number 27, it is called as DT bar R. It means that data transmit or receive, that is whether a processor is transmitting the data or receiving the data. If the function, if the value of this pin, that is if the pin is applied with logic 1, then data is transmitted. If this pin is applied with logic 0, then data is received in, and this is the active low signal. Next pin is called 28th pin, that is memory bar IO pin. Here, if logic 1 is applied to this pin, then memory is accessed, and if logic 0 is applied to this pin, then IO is applied, then IO is accessed. 29th pin is called write pin. It is also an active low pin. It is used to perform write operation, and this write operation is based on the status of this 28th pin memory bar IO. If it is 1, then the write operation is carried over memory. If the value of 28th pin is 0, then write operation is carried to IO. Next, 30th and 31st pin are hold, acknowledge and hold pin. So we know that the function of hold pin. So next, 30th pin and 31st pin are hold, acknowledge and hold pins. So whenever a processor receives hold request from any DMA controller, then the processor will surrender its system bus to the corresponding DMA controller. And so next pin, 30th pin is called as hold acknowledgement and 31st pin is called as hold pin. Whenever a DMA controller requires the control over the system bus, it requests the 8086 processor using this pin, hold pin, and if processor is ready to transfer or relinquish the control over the system bus, it sends an acknowledgement via HLDA pin, that is hold acknowledge. So these are all the 8 pins that have special purpose when the processor 8086 processor operates in the minimum mode. Next, we will discuss about the functions of pin in the maximum mode. Next is the functions of maximum mode pins. So pin number 24, when the 8086 works in, so this is the pin. So these are all the pin that executes special function when 80 executes in maximum mode. So the pin number 24 is called as QS1 and 25 is called as QS0. D refers to Q status. Q status, that is status of the 6-byte long instruction queue. So the status are QS1, QS0 and status. If the value of QS1 is 0 and QS0 is 0, then no operation is being executed at the instruction queue. If the value of QS1 is 0 and QS0 is 1, then it means that first byte of the queue is fetched. That is, first byte of opcode is fetched from the instruction. So the first byte of the opcode is fetched from the instruction queue. If the value of QS1 is 1 and QS0 is 0, it means that when the value of QS1 is 1 and QS0 is 0, it means that Q is empty. That means there is no opcode bytes in the 6-byte long instruction queue. When the value of QS1 is 1 and QS0 is also 1, it means that subsequent bytes of instruction queue are fetched. So this is the status of the queue, that is instruction queue. Next pins, pin number 26, 27 and 28, they are called as status pins indicated by S0, S1 and S2, and all of these are active low pins. So the status pins S2, S1, S0 and the status is when the value of all the pins are applied with logic 0, then the status is interrupt acknowledgement. When S2 is 0, S1 is 0 and S0 is 1, it means that memory read is executed. Then if S2 is 0, S1 is 1 and S0 is also 0, it means that memory write is executed. Then S2 is 0, S1 is 1 and S0 is also 1, then halt is executed. Next, when S2 is 1 and then S1 is 0 and then S0 is also 0, then no operation. When S2 is 1, S1 is 0, S0 is also, then IO read is executed. When S2 is 1, S1 is also 1 and S0 is 0, then IO write is executed. When all these pins are applied with logic 1, then the processor remains in passive state. It means it is in the idle state. So this is the functions of the 8086 processor based on these pins S0, S1 and S2. Next is 29th pin is called as lock pin. It is a lock pin and it is also a active low pin. Lock pin, when this lock pin is active low, it means that the processor is locked. It means that the processor is not ready to handle any interrupt request. So that is the function of this lock pin. So the next pin is called as 29th pin is called as lock pin. It means that when this pin is active low, the processor is locked. That is, no other interfacing device or IO device or any peripheral device can able to send interrupt request to this processor. It is not able to handle or it is not ready to handle the interrupt request. So that is the function of lock pin. And the 30th and 31st pin are request or grant pins. RQ request and GT grant pins. So these pins are used to receive and grant request for the system bus from the connected IO or peripheral devices. And the function of these pins are based on the status of lock pins. If it is locked or if the lock pin is active low, then these pins have no functions or these pins are not able to receive any request from the corresponding connected peripheral devices. If it is active high if it is active high, then 8086 processor can able to receive the request and further it sends the grant signal as an acknowledgement to the corresponding requesting IO device. So this is the function of request and grant pins. So these are all the functions about each and every pins of 8086 processor.